Hello there, Jose Rodriguez here, AKA Jtoolman1949. I am in my video editing area and I have my LittleMachineShop.com mini mill. It is the 3960 model of their high torque mini mill. And I want to give you a quick tour of the machine. You may have seen my previous couple of videos on the mini mill that I built in my shop with basic TEG microlathe components such as a headstock and the bed, the dovetail bed as a column. Well, this is actually a nice Asian design mini mill manufactured for LittleMachineShop.com. One of the features that it has, unlike some of the previous predecessors, is that the transmission, or the way that the motor transmits power to the spindle, is via a belt-driven mechanism rather than a geared mechanism. Those gears were actually not made of very good metal back in the older days, and they tended to just basically shear off if the mill ever crashed. In other words, if you drove a tool into a piece of work and caused the spindle to abruptly stop, you would literally shear off the teeth of the drivetrain, and you would have to remove the motor, which is not that difficult to do, and order new gears, which was a pain in the neck because you had to order them from China. Well, LittleMachineShop.com carries every single part, component, washer, screw that you would need to actually rebuild this mini mill if you had to. You could actually build it from scratch if you would like to go that route. It would cost you a fortune that way. You wouldn't want to do that. But anyway, I'm going to bring the camera up close and take you through all the different features of this little mini mill. Okay, here we're looking at the headstock, and I'll give you, in case you cannot read them off the video, I'll give you the specifications of the machine. The end mill capacity, or end milling capacity, is 60 millimeter, or just over half an inch, which is 0.6. Face milling capacity 1.2, 30 millimeters. Drilling capacity half inch, and so on. I won't give you the metrics. Table travel 11.8 inches on one axis, or the long axis, and I believe 5.1 on the short or Y axis. Head vertical travel 10.2 inches. The spindle taper is an R8, so you can actually utilize any R8 collet or R8 type spindle mounts for either your drill chuck or any other tooling that will fit on an R8. Spindle motor is a 0.67 horsepower, 500 watt. It is variable speed. Spindle speed is from 100 RPM to 2500 RPM. And you need 120 volt power, 8 amp power supply in your plug, which would be no problem. Most people have 11 amp on a regular wall plug. The weight is 139 pounds, make that 140 if you add a chuck. Lubrication, well, oil, everything that moves daily, if you use it daily, with SAE 30 weight oil. Here we have a side view of the machine. The on-off switch, this is the off switch. In case you run into trouble, just smack that and you are off. Once you turn on the on switch, the little green light will be lit, and then you can operate the spindle. And we'll look at that a little bit later. Let me go ahead and turn it off. And here we have the counterweight system that actually evens out the weight of the head as you try to raise it up and down along the column. It is actually spring-loaded. It's actually like a torsion bar. Now, the older ones utilize an air piston system, which wasn't that effective at all. So they have come back and switched to this type of system. This works beautifully. All of the wiring is neatly enclosed in these conduits, as you can see here. Behind the control box is a couple of covers for your fuses in case you ever have to replace them. You will probably only have to do that if you overload the machine for any reason. You have a scale here with a little pointer. I don't really use it, to tell you the truth. And back here is a junction box which contains all of the electricals. The motherboard for the controller, in other words the speed controller, resides back here. And located directly on top is the motor housing. Like I said, it is a just over a half horsepower 500-watt motor. It's variable speed. I think it's DC motor. And as you saw, it's very quiet. You can actually mill, and the milling process will probably make a lot more noise than this motor actually produces. And on the opposite side, you have your fine dial adjusting wheel for the Z-axis. Right now I have it set so that you use it only in manual mode, meaning that you turn the handle. And you would utilize for drilling, this for drilling or for raising the head several inches at a time quickly. There's a stop here that prevents you from drilling any further than you need to. Now if you want to utilize the controller here, or the dial controller, which operates in thousandths of an inch, you have to engage this. And it's a little bit tricky, but you just basically push the handle and it will mate against a set of teeth. And now you simply use the actual dial to move the head up and down in thousandths of an inch. And as you can see, as I move the dial, the head moves up and down. And it's quite accurate for what it is. Now the only crazy thing is that each revolution equals to 60 thousandths of an inch, which is a bit odd. But the dials are resettable. You can actually set them to 0 and then advance whatever amount you wish to advance. We'll take a quick peek at the XY table. I'll move it over to the left slightly. We have give lock, give adjusters here, and there is a matching set of adjusters on the underneath the X slide, and they operate in the same manner. And I have this set so that it is fairly tight but not super tight. I only have about maybe 4 thousandths, maybe 3 thousandths backlash. The dial is resettable to 0, so it's actually works out quite well. And again, it's that crazy, this is even worse. This is 62 and a half or 62.5 thousandths per revolution, which I believe equates to, if I'm not mistaken, to 1/16th of an inch. So you can actually, if you want to work in inch measurements, you can actually utilize this quite well. But most of us work in decimals, so this doesn't quite work out. Most of the time you either have 50 thousandths per revolution or 100 thousandths per revolution. But you can work around that, and I have found that I am not having any problem dealing with that. Mounted on the table, I have a Asian basic screw vise. It's one of those that you can pick up for like 40 bucks. Operates quite nicely. Not a problem. And to end this, I have just another thing to tell you. As you can see, I have my 1/2 inch drill chuck here that is attached to a holder just like this. Okay, so it's regular, an arbor, I should say an arbor that's R8. And it just literally fits behind the chuck. It locks in place and you're good to go. To remove it, there's a little cover on top. You remove that, loosen a nut. It's got a drawbar. Give it a little tap and the collet or holder will fall right out. And you just should hold it and it'll slide right out. And then you can reinsert the next holder with whatever tool you are about to use. So it's quite nice. And I love the fact that it's large enough to use the very commonly available R8 collets and holders. Alright, well, I hope you enjoyed this little tour. If you want to know more about these tools, just go directly to www.littlemachineshop.com and check it out. And if you're there, go to the video section if you would like. I have multitude of video titles there on DVD that are sold directly through LittleMachineShop.com. In case anyone is interested, these are full feature DVDs lasting from half an hour to over 4 hours long per disc. Alright, Don't forget to like it if you like this video. Don't forget to subscribe. I need to get this channel really going, and it's growing slowly, but it's getting there. And so, until the next time, happy machining. Bye-bye.